this quadratically, our focus will be on A. B is going to be seen as ordinary number. So our focus is A. So 4 times 9, 36. The center here we have minus 12. What can we multiply to get 36? And add to get minus 12? The answer is obviously minus 6. Minus 6. Because minus 6 plus minus 6 gives minus 12. Minus 6 multiplied by minus 6 gives 36. So this becomes 4a squared minus 6ab minus 6ab plus 9b squared. Here 2a is common, so we have what? 2a minus 3b minus 2b is common, that's 2a minus 3b. Sorry, 3b is common here. So from here we have 2a minus 3b common, and we left 2a minus 3b. And this gives what? 2a minus 3b all squared. Simple as this. That is the perfect square. Then we can proceed. How? This is now difference of two squares. Everything here carries square, this carries square. So what I meant to do, we subtract first. So we have 2a minus 3b, then minus c. Then we add 2a minus 3b this side, then plus c. That's the final answer. If we expand this, we get this. This particular problem, most students will get stuck because they won't know that here we have two perfect squares and one looks like a quadratic expression or is a quadratic expression. So, and you know, in exam mode, when you see this kind of question for the first time, you might get confused. That is why it is necessary to solve lots of questions so that you gain confidence, enough confidence to face any problem, any random problem. Now, when we look at this question, you don't have to panic. I have m cubed m squared. Here m squared is common. So if we factorize m squared, here we will let it m minus 2. Then for this one, nothing is common. Leave this minus here first. If nothing is common, write 1 there. We have m. Note, it is as though we factorize minus. When we take out minus, this plus comes to minus. And at the end, m minus 2 is common. We have m minus 2. Then what will be left here? M squared minus 1. Already most of them want to stop here, but recall 1 is same thing as 1 squared. So this part is actually difference of two squares. So this is m minus 2. For this one, we subtract m minus 1, then we add m plus 1. And that is the final answer. Let's take another UTME question. Now look at this question. Factorize 1 minus a minus b all squared. They didn't put the square there, but you should know 1 squared is same thing as 1. So directly difference of two squares. So we subtract. So that will be 1 minus, what do you have here? A minus b. But please put inside another bracket. Not just write minus a minus b. You get it wrong. After subtracting, next is to add 1 plus, what do you have here? A minus b. It is safer if you're doing this form. You just write plus a minus b. This side might not make a mistake, but we do the same thing here. If you write 1 minus a minus b, that will be wrong. It's actually meant to be 1 minus a plus b. Why? Let's explain and see. Minus affects a minus a, minus plus b. So if you write directly, you read it as minus, which is going to be wrong. Then here we have 1 plus will not affect the sign a minus b. So this is the final answer for the factorization of 1 minus a minus b all squared. Let's take another question. UTME 1994 question 10. We have to simplify this. What notice the difference of two squares? So what I meant to do here, we subtract this from this. So we're having 2m minus u minus, what do you have here? M minus 2u. This is for subtracting a minus b. Then let's add a plus b. Then we add this with this. That will be 2m minus u plus m minus 2u. So we've done difference of two squares there. Okay, denominator. At the denominator, 5 is common. We can bring out 5. We'll be left with m squared minus u squared. Then for the numerator for this first bracket, we are having 2m minus u. This minus affects m, minus m. Minus with minus plus 2u. Then the second one here, we have 2m minus u. Then plus m minus 2u. Divided by, we have 5 here. Then this was different of two squares again. M squared minus u squared. So we subtract m minus u, we add m plus u. That's what happened here. 2m minus m is m. Minus u plus 2u is u. 2m plus m, that's 3m. Minus u minus 2u is minus 3u. Divided by 5 into m minus u, m plus u. If you notice very well, this m plus u. So this can cancel this, since what connect them is multiplication. So if you look at the numerator here, 3 is common. So if you factorize 3, we're having 3 into m minus u. And at the denominator we have 5 into m minus u. What again? They are the same. So m minus u cancels m minus 2 and m minus u. So the final answer is what? 3 divided by 5. Look at the question. Look at the answer. Okay, look at this question. We have to simplify this. When you look at the numerator, we notice that x is common to the numerator. So if we factorize x, this turns to x squared plus 3x minus 10 divided by 2 is common, 2 into x squared minus 4. So this becomes x into, now this is a quadratic expression. So what can we multiply to get minus 10 and add to get 3? So the answer is 5 and minus 2. So there, if you factorize this, you should be getting x plus 5 and x minus 2. If you expand this, you get this. We've done that previously. That's 2 into, I can write this 4 as 2 squared. If I have x squared minus 2 squared, difference of 2 squares we subtract x minus 2, then we add x plus 2. By doing so, if you observe, you see that we have x minus 2 here, we have x minus 2 here. By the time we cancel, we will be left with x into x plus 5 at the numerator, and at the denominator we have 2 into x plus 2. And nothing here can cancel. That is the final answer. For this, factorize 81 a raised to power 4 minus 16 a raised to power 4. So first, express 81 as power 4, and that's obviously 3. Because if we raise 3 to power 4, it is 81. And when we raise 2 to power 4, it becomes 16. So this 81 can be written as 3 raised to power 4. We have a to the power of 4 minus 2 to the power of 4, b to the power of 4. So this becomes 3a to the power of 4 minus 2b to the power of 4. 2. We have to express it in 2. So 4 is 2 times 2. So that's 3a all squared to the power of 2. Then minus 2b all squared to the power of 2. So what next? We can now apply difference of 2 squares. So everything here is 3a squared, 2b squared. So this becomes, we subtract this from this. That is 3a all squared minus 2b all squared. That is for subtracting. Then let's add. If you have to add, we have what here? 3a all squared plus 2b all squared. Then, if you notice, this is another what? Square, difference of 2 squares. If you go for that here, subtract first, this becomes what? 3a minus 2b. Then let's add 3a plus 2b. This represents what we have here. Then for this, square or sum of 2 squares doesn't have any what? Factor. So we just expand. 3 squared is 9, so this becomes 9a squared plus 4b squared. And this is the final answer. So the expansion of this gives this. So meaning this has 3 factors. 3 minus 2b, 3 plus 2b, and 9a squared plus 4b. I believe with this example, no matter the kind of what expression you are given of fraction, you should be able to simplify. Alright, before this class, we've learned how to add and how to add fractions, how to subtract, division, and the likes. So in our next class, for example, if we have 3 over 2 plus x minus 2 over 1 minus x, if we have something like this and we are told to write as a single fraction, I believe you know how to do that. That will be 2 plus x into 1 minus x. Then when 2 plus x cancel this, I have 1 minus x multiplying 3. That will be 3 into 1 minus x. Then this minus remains. Then 1 minus x cancel minus x, 1 minus x, we have 2 plus x multiplying 2. So we are having 2 into 2 plus x. From there, we'll be having 3 minus 3x minus 4 minus 2x over 2 plus x, 1 minus x. So in this case, 3 minus 4, that's minus 1, minus 3 minus 2 minus 5x divided by 2 plus x, 1 minus x. So if you are given any fraction to add or subtract, I believe you know how to do that using the concept of what? LCM. So in our next class, we'll talk about when two fractions are combined to get, to have a fraction in the same form. If you can move from here down to this, can we move from here back to this? If we add two fractions, can we split the single fraction into partial fractions? And that's the name of the topic. So in our next class, we move to partial fraction. How to, if you have a particular fraction, how we take it back to its fragment. But before that, let's take some examples whereby we apply, expansion formula. I think we've used factorization formula. We've used virtually all this formula in solving question. This one is not really useful. We've stopped choosing this and this particularly. So all these one are useful if you want to save time in expansion. Let's give little examples here. Some examples. So my assumption is we are good to go when we talk about factorization. Now let's take examples on expansion. Okay, look at the following examples. This is square of sum, so we have to use this formula. This formula means we square the first plus twice the product, then we square the second. If you apply same thing here, we square the first, that's 2x all squared. Then plus twice their product, 2x and 3. Then we square the second, 3 all squared. Then this becomes 2 squared, 4. Then we have x squared. 2 times 2, 4. 4 times 3, 12. That's 12x. 3 squared, 9. Final answer. This is square of difference, which is the second one. We square the first, minus twice the product, square the second. We square the first, minus twice their product, that is 2x, multiply 3, plus you square the second, 3 is the second number. So from here this becomes 4x squared, minus 2 times 2, 4 times 3, 12, 12x, 3 squared, 9. Next, cube of sum. What's cube of sum? You cube the first, plus twice square the first and the second, then 3 the first, square the second, then cube the third, the second rather. So a cube, this is our a, 2x is our a, so we do 2x all cube. Then plus 3, we square the first, which is 2x, we square the first, 2x, then multiply by the second, which is 3, plus we don't write 3 again, 3, leave the first, which is what, 2x, then square the second, b, which is 3 here, then plus cube the second, that's 3 all cube. Then what next? 2 cube, 8, then s cube, plus 2 squared, 4, 3 times 3, 9, 4 times 9, 36, then this x 3 squared, s squared, plus 3 squared, 9, 9 times 3, 27, times 2, 54, then this x has no extra power, then 3 cube, 27. That is the advantage of the identity. For this one, cube the first, 2s all cube, because you have minus here, you have to follow this pattern. Then minus 3, you square the first, a squared, our a is 2x here, you square the first, then the second, you have to put the second beside it, b is 3 here beside it, then plus 3, leave the first with no power, the first is 2x, 2x. Then square the second. The second is b, which is 3 here. You square the second. Then minus, we cube the third, b cube, 3 cube. From here, 2 cube is 8, we have s cube. Then 2 squared, 4. 4 times 3, 12. 12 times 3, 36. Plus 3 squared, 9. 9 times 3, 27 times 2, 54. 54x minus 27. Wait, yeah, that's the final answer. So meaning with this, I believe you should know how to use square of sum, square of difference, cube of sum, and cube of difference. Sometimes you can have mixed questions. For example, look at this example. We are told to expand. So, square, no problem. What is 2x minus 3 all squared? We have to follow this approach. If you expand, you get this. And that is 4x squared minus 12x plus 9. Then plus 2x plus 3 all squared, which is the first one. 2x plus 3 all squared, that's 4x squared plus 12x plus 9. What happens here? 4x squared plus 4x squared, 8x squared. Remember, we can only add like terms. Here we have xx plus 12x minus 12x cancel each other. 9 plus 9, 18. Same can go for cube. We can have 2x minus 3, or is it plus 3 all cube, then plus 2x minus 3 all cube. In that case, we have to do 2x plus 3 all cube, which we've done here. So that is 8s cube plus 36s squared plus 54x plus 27, then plus 2x minus 3 all cube. What do you have it here? This is s cube minus 36s squared plus 54x minus 27. So what do you notice? 36s squared minus 36s squared. 27 minus 27. So we have 8s cube, which is 16s cube. 54x, and that is 108x. We are told to expand, so you don't have to, factorize. Although 2x is common there, or even 4x, but we don't have to factorize. Recall that what brought us here is binomial expansion. Binomial expansion of a plus b. We did power of 0, 1, 2, and 3. But as the power increases, expanding formula becomes useless. What if you have a plus b or raised power 12? What are you going to do in this case? So that will lead us to binomial theorem. So this will be the arrangement. Next class, partial fraction, which is the reverse of addition of what? Algebraic fractions. After that, we'll now move back to binomial expansion. Although before that, we ought to look into permutation combination because we need that idea here. But for now, we can still go on with this because that other topic is also wide. So the arrangement is next class partial fraction, the following class binomial expansion, which are going to link to binomial theorem. Then after that, then we'll now move to permutation and combination. So see you in my next class.